everyone, this is Galadrin and welcome to the second video of this channel. Today I am going to bring you a video about the universe, so on a different topic from the previous video. And universe is something that I've always liked to study and to learn about since I was in the high school. I always been searching information, news on these topics to discover how it works, where it came from, and all the mechanics that there are in the universe that, in my opinion, are really fascinating. And today, I wanted to bring you a video on the origins of the universe. So the Big Bang, that as we know is the most accepted theory by the scientists for the origin of everything. So without further ado, I hope that you enjoy this video and let's get started. The universe is a very big place and it's been around for a very long time. According to the latest measurements, the universe is 13.7 billion years old and contains billions and billions of stars and galaxies, more than every grain of sand on the earth. It has constantly changed and evolved during its lifetime and will keep doing it. But where did everything come from? In 1927, Georges Lemaitre, a Belgian Catholic priest, astronomer, and professor of physics, had a big idea. He said that a very long time ago, the universe started at just a single point. He said the universe stretched and expanded to get as big as it is now, and that it could keep on stretching. Just 2 years later, another astronomer named Edwin Hubble, maybe somebody may have heard of it, noticed that other galaxies were moving away from us. And that's not all. The farthest galaxy were moving faster than the one close to us. Lemaitre theories were confirmed in some way because the things were moving apart. And that meant that long ago everything had been close together. After many years, the theory of the Big Bang has been refined, discovering the various phases of the development of the universe thanks to telescopes observation. And now it is mostly accepted by astronomers to explain the way the universe began. It is important to say that it was not an explosion, as the name may suggest, but an expansion from a single point of infinite density and heat. This because an explosion is a sudden release of energy from a point, generating light, heat, pressure, and a bang. While during the Big Bang there was no air, the sound could spread in, so everything was silence. Also, there is no real point in the universe you can name as the center of the Big Bang. This because the Big Bang happened everywhere at the same time. It is difficult to imagine, but let's consider this. If we look at the sky through some telescopes, we are looking back in time, because we see the light of stars and galaxies not in real time, but as it was when it started from the actual star or galaxy. So this light can be 100, 1,000 or billion of light years old. Looking backward in this way, we will notice all the stars are red-shifted in the spectrum of the colors, and we can find them in all directions we look at. This leads to the conclusion that everywhere in the universe there are the same properties. The universe is homogeneous, and it has born everywhere at the same time. It was actually Fred Hoyle, an English astronomer, who coined the name of Lemaitre theory, referring to it as the Big Bang idea, during a radio broadcast on 1949 on a BBC program. But exactly what are the phases the Big Bang went through during its initial moments? There is still some speculation on what happened in the initial phases since astronomical data are not completely clear, but in the most common models, from 0 to 10 to minus 43 part of a second into the expansion, that is 0 followed by 42 0 and 1, the universe was filled homogeneously and isotropically with a very high energy density and huge temperatures and pressures. The universe was pure energy at this stage, too hot for any particles to be created. At approximately 10 to minus 37 seconds into the expansion, a phase transition caused a cosmic inflation, during which the universe began growing exponentially faster than the speed of light, and temperatures began to drop. In this phase, there was no time and no space. It was the universe that inflating was creating both of them. The inflation stopped around 10 to minus 33 seconds, with the universe volume having increased massively by a factor of at least 10 to 78. Some reheating occurred until the universe obtained the temperatures required for the production of a quark-gluon plasma as well as other elementary particles. This state of matter happens when elementary particles are freed of their strong attraction for one another under extremely high energy density. At this time, temperatures were so high that the random motion of particles were at relativistic speed, and particle and antiparticle pairs of all kinds were being continuously created and destroyed in collisions. At some point, an unknown reaction called baryogenesis led to a very small excess of quarks over antiquarks and other subatomic particles over their antiparticle of the order of 1 part in 30 million. This resulted in the predominance of matter over antimatter in the present universe. This matter, known as baryonic matter, is the matter which the stars, galaxies, and ourselves are made of. At about 10 to minus 6 seconds, quarks and gluons combined to form protons and neutrons. A few minutes into the expansion, when the temperature was about 1 billion Kelvin and the density of matter of the universe was comparable to the current density of Earth's atmosphere, neutrons combined with protons and formed the first deuterium and helium nuclei. This will be the basis for the future atoms. It took about 379,000 years before the electrons and nuclei combined into atoms, mostly hydrogen, and they started to emit radiation. This relic radiation is known as the cosmic microwave background radiation. Giant clouds of these primordial elements later gathered through gravity, forming early stars and galaxies, the descendants of which are visible today.